IWACP and the first AWPPO. Our work, entitled Mapping the Seasonality of Marine Debris Waste in a Tropical Tourist Hotspot, was supervised by me and Dr. Jesse Marx Pavão, and was conducted by our team in the lab. Just to put in a local perspective, our study site is the city of Maceió in Alagoas State, in northeastern Brazil. Maceió is a touristic city where many of the exploitation of the tourism comes from the coastal areas. However, we do have a serious marine debris issue, mostly due to the accumulation of debris in the coast, especially coming through the drainage systems and tourism activity. The debris in coastal areas is a waste production problem, which is global. And in coastal cities, there are several related issues. The poor waste management from part of the government agencies, lack of infrastructure, low environmental literacy from the population, and many others, such as communal habits or the lack of access to disposal systems. In coastal areas, most of the marine debris, it comes from river and drainage systems, which with the rainfall, if you have a higher rainfall, you have a higher flow of sewage and increased river discharge, especially in the rainy season. And anthropogenic actions, mostly in the summer seasons, with higher human activity and consequently higher waste generation. The seasonality in the tropics, we don't have 4 seasons like in temperate areas. But in tropical regions, we have basically a dry and a rainy season. And the rainfall patterns, they define the seasons, mostly characterized by wind direction. In northeastern Brazil, we have from April to August a rainy season, which is our winter, and September to March with our dry season, which is basically our summer. And as a tourist hotspot, we have a variation of the amount of people in the city and the population density throughout the year. Mostly in the dry season months, especially December and January, we have a high number of passengers arriving per flight in our airport, according to data from the flight agencies. Our study site, the city of Maceió, have a few characteristics. We have a number of hotels in the coast, and we have a few key points here. However, it's important to highlight how the seasons work. In the dry season, with the northeastern winds, our wind-driven currents, they turn, due to the economic transport, the currents, the coastal currents, 45 degrees to the left, which means that these currents will run south. In the rainy season, with the southeastern winds, we have the wind-driven currents also turning to the left, due to the economic transport, to west. In our study, we decided to evaluate the seasonality of the floating marine debris in the urban area of the tropical tourist hotspot, which is the city of Maceió. We aim also to identify seasonal and local patterns in 3 urban beaches with distinct biogeographical features, and provide a technique to identify marine debris patterns for local authorities, environmental organizations, and policymakers, and thus helping to develop management plans. We basically use a coding on the Google Earth engine using Sentinel-2 images, which shows 3 urban beaches and a 3-year timeline, transects of 500 meters from the shoreline. We only use pictures with cloud cover of less than 20% and grids of 10 meters square. The bands are the blue, B2, green, B3, red, B4, and the near-infrared, B8. Normalized difference vegetation index was selected to separate what is vegetation from debris. The floating debris index to identify all the debris floating, and the normalized difference water index to separate which is water from land. Our overall results show that in the dry season, from April to August, we have a higher accumulation of debris, especially in transects 2 and 1, especially in the most southern part of this transect. And in the rainy season, we have overall more or less the same amount of debris. However, they were accumulating in certain areas. In transect 3, mostly due the currents of the rainy season pushing southward. We have a higher accumulation near a construction that we have inside the water there. We call Marco dos Corais. I'm talking about this very soon. And on the other side, so these constructions inside the water, such as the port of Maceió, and which is between transects 1 and 2, and the Marco dos Corais, which is a construction inside the water between transects 2 and 3, they change the dynamic of the currents in the area, probably affecting the results. Our statistical analysis indicated that the location have a higher effect, a more significant effect, and we didn't have much difference between the transects, only between the dry season of transects 2 and transects 3. Another thing important to highlight here is that there was a tendency to accumulate different levels of debris during the dry season in transects 1 and 2, and the rainy season, all the transects were similar. There was no statistical differences between them. Our key findings is, firstly, we don't have any seasonal effects detected within the selected transects at the time range, despite the tendency towards difference in T2. We have a high floating marine debris detected in the dry season in the transects 1 and 2. Between transects 1 and 2, we have similar floating marine debris results obtained for dry seasons differentiated from T3. Transects 1, 2, and 3 presented no differences between the rainy seasons. We conclude that we have a very likely influence of anthropic density, especially in the dry season. The wind-driven currents and anthropogenic factors, as tourism density, may play a decisive role in debris accumulation in these areas. Our study, we agree and we acknowledge that we have a few limitations, which is debris source information, because recent studies have been proven that some of the debris in northeastern coast, they're coming from larger currents, such as the Brazil current, and probably coming from the high Atlantic, and oceanographic data. We could not get our hands on the oceanographic data by the Navy, which would validate the direction of the currents and the winds. For future studies, we are planning some multimodal approaches using drones and other gears to describe the direction and intensity of currents. And we are going to increase the areas of study and the timetable, probably getting more years and increasing the areas. Our team would like to thank SESMAC, our institution, our lab, the LEDI lab, the Laboratory of Energy and Resilience of Ecosystems, our program of post-graduation and analysis of environmental system, PPGASA, our project, the Plastic Oceans, and we are part of the United Nations Decade of Ocean Science Sustainable Development Efforts. Thank you.